This one was pretty awesome because it's just like our last week's one.
The same? Yeah.
Yeah, I was like, oh.
That's what I thought. Yeah.
Yeah. First off, do we know if Taylor's going to be able to be in our group? Like,
I don't know. So today he said he had an appointment.
Yeah.
But he also can't meet on Thursdays, so I don't know.
Yeah.
I don't know.
I guess we'll figure it out next week. I guess I was I wanted to know because doing like our group project, like, yeah.
Yeah.
Just to see if you had any input or ideas or things like that.
Yeah.
Okay. Cool. Well, how was the homework for you? Was it okay?
Yeah, I just breezed through it. Basically, I was like, okay, I know that.
Yeah, it was really easy. Normally it takes me a while, but this one didn't take me very long, so that was really nice.
Yeah.
Okay, cool. Then do we want to go straight into the quiz and see if we got it?
Yes. Yeah.
Okay, sweet. See, I even pulled up the quiz.
Ooh.
Like I even opened it. I'm way on top of it. Okay. So 1 and 2. So for these next questions, it says, suppose we have a set of paired data and let D equal X after minus X before. The null hypothesis is the mean equals 0, and the alternate hypothesis is the mean does not equal 0. The population standard deviation is not known. Jordan collects a sample size 9 and computes 2.2 is the mean of the difference, and the standard deviation of the difference is 3.3. Okay, that's a lot of info.
Yeah, so
Write that down.
Busy. Yeah, I just finished homework.
Okay. So this first question, what is the value of the test statistic? And that's where to solve for t.
Yeah.
In this case, they don't give us the null hypothesis. Or, I mean, it's 0, just kidding.
Did you get it?
Yes. I got 0.22222.
Oh no, I only got 2.
Oh, you got 2?
Yeah.
Because we do the the difference mean. So the mean of the difference is minus the null hypothesis, which is 0, right?
Yeah.
And then divide that by the standard deviation, or 3.3, divided by the, that was me, divided by the square root.
Oh, okay. I was like, oh no.
I'm like double checking it. I thought I did it. Oh, no, didn't do it right. I don't hate when that happens because then you're all worried. You're like, uh-oh.
Yeah.
You're good. You're good, Caitlin. Okay. Divided by, there we go. Square root of 9. Okay. Yep. No, I got 2 as well. Sweet.
Okay.
Just 2.
Makes you feel better. That's a nice number, though. Okay. Question 4. The probability of obtaining a statistic greater than Jordan's statistic is 0.0403. Use this probability to determine the p-value for his hypothesis test. Okay, so do we just plug it into the applet?
Yeah. Since it's the not equal to, it's the two-sided, right?
Yeah. Yeah.
Yeah.
Oh, wow.
Did you
So I
get a
got
number?
0.971. No, 0.970.
Oh, with you just put in 2? Oh, because I got
Do we use
0.1393.
Or do we use that 0.0403 in the question?
Hold on, wait. So what did you use to? Oh, okay. I'm having a slow day.
I'm not.
Okay, so. Oh, so you put that in as the probability. Oh, sorry.
I'm not really sure if you're only supposed to do one side because it's greater than, or
Oh,
use the
no, I'm
original.
doing it
not
wrong.
sure.
No, it's me today. I'm having a.
One of those days.
Yeah, I'm like, I had a job interview today and.
How'd it go?
I can do it. Yeah, my test went well, but I don't know about the job interview till. Fingers crossed.
Oh, gotcha.
But anyway, okay. So you got. Oh wait. Yeah. I got 3 point. Wait, because we put in the number they gave us into the area, which is on the top, right?
So, yeah, so if we just do that one side, then it's 0.485. Is that what you got?
Oh, on the one side, I'm doing both.
Or yeah, I'm not sure. So
Oh,
I don't know what to do exactly.
wait. Because they already gave us the probability. But then I thought that's what the p-value was. Oh, because it says the probability of it being greater than was that number. But we have to do also less than. Oh, so wouldn't we just add them together? Because that's one side of the tail. Oh, maybe I'm gonna try that.
0.806. 0.806.
Yeah, 0.0806. Yeah, that's what I got as well. But I'm gonna double check it on this. Because the t is about 2.5.
Mm-hmm.
Would you agree that it would have to be a two-tailed probability because we're doing the or the alternate hypothesis? Yeah, it's unequal. Because
I'm not sure.
I drew pictures for that one because they drew. Yeah, where it's two-tailed, like on my notes, it says if it's two-tailed, then it's the outsides. If it's less than, it's on the left side. But if it's greater than, it's the right side plus the middle.
Yeah.
Yeah, and a large p-value is when you've got a lot of shaded area and there's little space in between. And then the small p-value is when it's they're way out on the tails. Yeah, okay.
Yeah.
So it's supposed to be two-sided, but they only gave us one side. And I think they're exactly equal, right? Okay.
Yeah, because that would be equal, I believe.
Yeah, so if we add them together, we just times it by 2, right? So it's 0.0806.
I'd be okay to go with that and see, because I'm not sure how to do those exactly. So
Yeah.
it'd be
And
good to
then,
know.
yeah. 3 decimal places would be what? 0.081? 0.
That's right. Serious.
This next one, we have to use one of these data sets. So perform a paired samples t-test. You should level of significance is 0.10. Oh. And so this is where we plug all this information into our little Excel.
You what? Sorry?
Oh, we're plugging in all the data from this Excel thing onto the one for the t values.
Yeah. Yeah.
Because we like subtract first, right?
Yeah. So you'll do group 1 minus group 2, and then take all 3 columns and plug it into the other one.
Yeah. Half the battle is trying to figure out Excel. I think I get.
Did you get an answer? You got what? Sorry?
Is it a bit loud? I'm in the what is it? Between
By the library.
yeah, is it quite loud?
It's a little. It keeps breaking out a little bit, but
Yeah, and I'm not in a very good spot for internet anyway.
so I got 6.43. So you got.
Sorry, my data set just wasn't copied. Okay, so we're trying to find the t value.
Yeah.
I got negative 0.538 on Excel, but I think I'm gonna double check because
Okay. I will too.
oh wait, because we have to put in the null hypothesis is 0.
Yeah.
So 0 or negative 0.407.
Okay. Because I got a huge T-score. So I'll redo it really quick.
Because did you do the second group minus the first?
So it said.
Oh, group 1 minus group 2. Oh. Nope, just kidding. Wrong. They're having us do it backwards because normally it's like the second group minus the first group.
Yeah. That's how it was last time, and I was like, ugh.
No, it's different. So, Group 1 minus group 2.
So did you get an answer?
Okay, I'm gonna double check though, because yes, I didn't get a big T score though. I got 0.407.
You got a what? T-score, sorry?
I got 0.407.
Oh, God.
That's weird. Okay.
I got 6.243.
What did you get?
6.243.
Oh, interesting.
That's way different.
No, because the null hypothesis is 0, not equal to, and let's see.
Level of confidence is 0.9. Oh, wait a second. Is it a one sample t-test? Or is it paired? Two or what?
Am I using the wrong one?
Paired sample. Oh, I did the wrong one. Oh no. Okay, I'm so sorry.
Oh no. Okay, wait. What was the difference, or what was?
So I was on one sample t-test instead of two or paired sample or whatever. Yeah, now I got 0.4.
Oh, so does it say like 2 sample t-tests on the top?
Yeah, so it says perform a paired sample t-test.
Yeah, which is 2. Oh, but can we still use the 1 sample t-test like Excel thing? I hope so. That's what I've been using.
I don't know, because when I changed it to paired sample, it was a completely different answer.
Okay, how did you change it to paired sample?
So just there at the bottom, there's like little.
Oh, 1 sample. Oh. Okay, how do I change that? 1 sample. 2. What did you have to do to change it to 2 sample?
So I just clicked on it and then re-pasted my data in there.
Oh, do we have to like add another variable?
Oh my gosh, I don't know.
I don't know, because this.
I didn't even think about that.
Okay,
oh my
I'm gonna
gosh.
go over the, because that's what I did for the homework and it seemed to work, but let's see. Because it said so you calculate the difference and then you put the difference. Okay, just. I love technology, right?
I didn't even think about it. But I still got 0.407 when I changed it. Isn't that what you got the first time?
Yeah, that is what I got. But
Yeah.
this is not opening. Oh, because it says it's like a or it's a paired sample test, but it comes up as the one I already was doing. That's weird.
Oh, yeah.
One sample test. It's okay. Well, then I'll just keep mine. So is that what you got? You got the 4.4.
407, yeah.
Or 7? Yeah.
Okay. And then number 6, what's the p-value? 0.89, or no, 0.689. Is that what you got?
I'm a bit slow. I'm putting in the test. I have so many tabs up right now, so I feel like I'm trying to. Okay. Hold on. So, question 6 was a p-value. Okay. Which is p-value, the 0.68877.
Yeah.
So it'd be just 0.689.
Okay, what's the correct decision based on the evidence?
Because they said that the level of significance is 0.10, and that's greater than that. So
Yeah, so then we fail to reject it.
yes, okay. Then number 8, suppose your alternative hypothesis is instead the mean of the difference is greater than 0. What is a correct decision based on this evidence? Let's see. It says we have insufficient evidence that the mean of the difference is equal to 0. We've insufficient. No, I'm not gonna read all of them. Just kidding. I'm just kidding. Yeah.
So my new p-value was 0.344.
Mm-hmm.
And that's still greater.
Oh, because it would change. Oh, no. Because. I don't actually know. Hold on. Because the only thing that changes is the p-value. I don't think it changes t. So I think it would still be the same. I think.
Yeah. I think so as well.
But we failed. Yeah, we failed to reject the hypothesis, though.
Yeah.
So which means the hypothesis is correct, that the mean of the difference is 0.
So we have insufficient evidence that it's greater.
Yeah. Yeah. So the second.
Those ones always trip me up.
I know when you put it into English, it's like numbers make sense, but English maybe not so much.
Yeah.
Okay.
Okay, new data.
Okay. So we're still doing group 1 minus group 2. Okay. Yeah. I don't know what's happened to my voice just right now, but
That's okay.
maybe it's because I'm having to talk louder because there's people. I don't know. Okay.
We didn't even have to do that for that one, but still.
What? Oh, I was just finishing.
But we do have.
Okay, I was
So
like,
N
oh
is-
man.
That's what I got.
Okay, so what is it asking? This first question is, which is greater? N, or the sample size or the freedom?
Whatever that means. Yes.
Yeah, I know it's freedom.
So
It's
N
something freedom.
degrees of freedom. Anyway, so N is greater because DF is N minus 1. So
Okay, because N is 22 and then DF is 21. Yeah, so N is greater.
is what?
So N is greater because it's
Yeah,
22
N is
and
greater.
then DF is 21. Okay. Question 10. What is the p value?
We got 0.002.
Yep, 0.0012. Yeah. But then this one we would.
So we had to change confidence level, didn't we?
Oh, you kind of cut out.
Do we have to change confidence level to 99?
Now that changes the confidence interval. But if you do the null hypothesis, we change.
Okay, because my p-value is 0.00207. So it's different than yours.
Did you do well, the type of test. Change.
That's true. So it's not equal to, right?
I'm going to simplify this. Okay, I'm actually going to. Oh, okay.
Okay, so are you ready for 11?
Oh, so is that the one you decided to go with?
So for number 10.
Yeah.
Yeah, so for number 10, I got 0.002.
Mm-hmm. Oh, yeah. Well, yeah. 001. Or would we round it to, oh my goodness. Sometimes this happens where, like, if I do a lot of stuff on the Excel sheet, clear it and then, yeah, do it again to make sure I get the
Yeah.
the same. So 0.00 1, 2. So like if we're just doing the 3 decimals, it'd be 0.001.
So what was your sample size?
22.
Okay. It's a good thing you keep me in line. Yeah. Sheesh. I didn't change it from the last one. That's why. Okay, yeah, 0.1. Okay. Thank you for making me check.
Okay.
So what decision do we make?
Because this one, because I said level of significance is 0.01, but this is a lot smaller than that. So we would reject the null hypothesis.
Yeah, that's fine. Okay. Number 12, you decide to try another alternative hypothesis. This time you use that the mean is greater than 0, and you keep the same level of significance. Did the p-value increase or decrease? Wait.
Wait, hold on. What was it before? Did we do not equal to? So, yeah, not equal to, because that's both tails. But then when we use just one tail, it like halves it.
Yeah, so it's teeny tiny now.
Yeah.
It decreases.
So yeah, decreases. And then question 13, what decision do you make? Well, you still reject the null hypothesis. It's tiny.
Okay, based on your response from the previous question, which conclusion do you make? I have to think about these for a second.
I know, it's like, oh, English.
Yeah.
So we kind of have to decide two things. Do we have sufficient or insufficient evidence? And is there a mean difference or is there not a mean difference between the two groups? And hold on. So our hypothesis is that, and we're working on the question 12, right? Yes, okay, question 12. Okay, so our null hypothesis is that it equals 0. Our alternate is that it's greater than 0. And when we reject it, the null hypothesis, it means that we agree with that the difference is greater than 0. So we do have evidence that there is a difference.
Yeah, so
does that make sense?
That's what I have. I had C.
Yeah. The third one. We have sufficient evidence that there's a mean difference between two. Okay, yeah, I have to like think about it. Okay, what are we actually saying? Yeah. Okay. As we have seen, the p-value depends on the alternate hypothesis. In general, which alternate hypothesis will give the smallest p-value? Ooh. Wait, let me look at. I think it's one that's left-tailed.
Yeah, because right would be greater.
Yeah. Oh, wait a second. I'm actually questioning our answer to one of the previous questions.
Oh no.
Because I forget that when it's right-tailed, you... Okay, wait, question. When it's right-tailed, do you also include the middle of the applet as well? Or is it just the right tail? Because on my notes, like I've got it shaded that you do.
Oh.
And if we did, then it would probably be greater.
Oh yeah, because right-tailed is middle and right. Yeah, that was in like a couple chapters ago.
Yeah,
I
I'm
forgot.
having to flip back in my p-value notes. Okay, wait, I'm gonna double check. because, hold on, what question was that anyway? Oh yeah, because it's greater. So question 8
Okay.
is the one we were looking at, and we wanted to see if the p-value would make it greater than or less than the null hypothesis.
Yeah.
Okay, so what's the null hypothesis?
So the null was at 0.
So our p-value is 0.689.
Yeah, so it's pretty high.
Applet. 0. Okay, so then if we did this, it turns out to be 0.655. If I did it with the right and the middle.
Yeah, with the middle as
But
well.
hey, oh, but it still makes it bigger than the, what was the level of significance? Oh, 0.10. Okay, so it's a little bit smaller, but we would still like have the same outcome, right?
Yeah.
So we'd still have insufficient evidence.
Yeah, I feel like we did that right.
Okay.
Even though we didn't know it.
I was double checking. I'm like, oh, my math was off.
I guess we'll find out if we did it right or not.
It's true. Okay. I had a moment where I was like, oh, wait.
Yeah.
Okay, never mind. So we're at question 15, right?
Yes.
Okay. As we've seen, the p-value depends on the alternate hypothesis. In general, which alternate hypothesis will give the smallest p-value?
Is it when it's less?
Yeah,
That's what I was thinking.
I think so. Because that's where you only do the left tail.
Yeah, and not one of yeah.
Yeah, not
Okay.
right or two tails. Yeah.
Okay. Determine the 95% confidence interval for the mean difference between the two groups and put your answers below. Okay, so we're only changing confidence interval?
Yes. Okay, because that's when we put the 95 into the applet, right?
Or is that when we just change the level of confidence? Like,
oh, just kidding. Oh,
0.9.
I know what we're doing. Yes. That was like 2 chapters ago.
Yeah, I know. It's all these things that you're trying to remember. Yeah.
Yeah, and I'm like, wait, last chapter, all we had to do was change this. Oh, and mine's already 95 confidence. Okay. Sweet, that's awesome.
Okay. I don't remember how, I always mix up the point estimate though.
I think we might have decided that that was the null hypothesis, right? Oh, dang. Yeah, it was either the mean that we figured or the null hypothesis. Dang.
Okay, I'll go back and.
I think we figured that out on, was it our last quiz that we did? Let's see. Let me look at my notes.
Dr. Tanner. What's the point estimate? Okay, so here's the problem. It says the sample mean for 50 students is 541, okay? And then it says what's the point estimate, and it was 541.
Oh, okay. So it was the sample mean.
Yeah.
Okay, so this would be the sample mean, or I mean the difference. Mean.
The differences mean? Yeah. So 11.955. Is that what you're thinking?
Yeah. Well, let's see, because it's the mean. And, yeah, 11.955.
Okay. Margin of error. So what'd you get for that one?
That one, I'm trying to remember how you do this. Because it's not the standard error. Right. That's different.
Is it not?
No, because I remember on the last one I tried to use that one and it wasn't right. I was like, oh, what? Because the margin, I remember. Because the margin of error is the difference between the mean and the higher confidence interval and the mean and the lower confidence interval. Does that mean, or make sense? And then when you add them together, it's you double its value. But the margin of error is like half of the difference of the confidence intervals. Does that make sense?
I'm just trying to find my formula for it. But.
Yeah, because it was because you add and subtract the margin of error from the mean to get the confidence intervals. I remember that. So yeah, I forget the equation. Oh.
Oh my goodness.
Wait, so I'm gonna do this. 18. So if you take the intervals,
Okay. I honestly do not remember how to do this. Margin of error.
I'll check it, see if I'm right, and then I'll explain. It's confusing. Oh, yes. Okay. So this is my theory. I don't know how to explain it very well.
Okay.
But so the margin of error is the difference between the mean and the higher confidence interval. That's the margin of error. But then it's also the difference between the lower confidence interval and the mean. So that's going to be the same number. So I take the confidence interval, like the higher one, 18.607. And then
hold on, I gotta find.
Oh.
Okay.
I'm trying to say this in a clear way.
No, you're good. Okay.
So you take that number and then you minus the mean from it. So the 11.955. And it's 6.652, right?
Yeah.
Yeah. And then, so that's the margin of error. But then to check it, you measure the difference between the lower confidence interval and the mean. So I take the mean 11.955 and minus 5.303.
Or do you subtract 11.5?
Well, yeah, because you could do that as well. Because the 6.652 is the margin of error, but so when you add it to the mean,
it's the same.
Yeah, it's 18.605. But then if you subtract it from the mean, then it's 5.303.
Yeah. Okay.
Okay, that's just how I check it. But did that make sense?
Yeah, and so
Sort of.
So we just use 6.652 is the answer?
Yes, that's what I think.
Okay. We can go for it.
I hope it's right. Fingers. If I'm wrong, it's totally my fault. Okay.
No, it's okay.
Then question 18 just asks us to input the lower bound number.
Okay,
The
so
5.3.
5.303. Yeah. And then the upper is 18.607. Okay.
Oh, wow, that's it. Oh, sweet.
And then we're gonna see.
Finger. Really
19 out of
20. Oh, which one did we miss? Better not be margin of error. Oh, sweet, we got that one right. Just kidding.
Yeah. So then what are you thinking on question 15?
Oh,
That there's not enough info?
You know, it might be the not enough information.
Yeah, because it's not the other ones. But out of all of them, I'm okay to get that one wrong.
Yeah. Yeah. Oh, good. Okay. Sweet.
Oh, awesome.
Okay. Cool.
Sounds good. I guess. So do you know much about the group project?
That one, I was looking at it the other day. So pretty much we have to do what we've been doing in real life, if that makes sense. Let's see if I can pull up yeah, so we'll have to find something that we're interested in, like if we want to know how many chips are in a Doritos chip bag on average, you know, or if we want to know what are some, she gave some examples. Just like something that we might want to know. Like, oh, I know one of them was like, do people normally, like if they're walking behind a slow person, do they go around them or do they just wait? Or yeah, that was one of the examples she gave. But then she was like, don't use people for like surveys because it's hard to get approval for that from the school. But yeah, and then we just have to figure out how we're going to collect the data and how we're going to measure it and like what we're going to use. Are we going to use where sigma is known, or you know, paired sampling like we did, or we're just going to figure out how we want to find our answers. That makes sense.
Okay, well that's good to know because I read a little bit about it, but I wasn't really 100% what we were doing.
Yeah. So let's see. Yeah, so I'm gonna look over that sheet again, and then on Thursday, do we want to talk about, or I guess I can even text you, just what we want to do, and then like our idea.
Choose ideas.
Because there's also the sheet that we have to fill out that says what group member is going to do what, or which group member is going to do what, and so we could kind of figure that out on Thursday if we wanted.
Yeah. I guess we'll just have to do like a group text and see what Taylor's doing, if he's gonna choose a different group or that situation. But,
yeah, because that would be really helpful if you could be part of our group stuff. We could do a group project, but I think we're pretty capable. We could do it, but it would just be nicer because we're doing pretty well, man. Sometimes we don't even know what we're talking about.
Yeah.
But it still works.
I know.
I love that. Okay. Yeah. Okay. Cool. So yeah, at least by next Thursday, I think we should have our idea. Because I think the due date for that is did she say week? No.
It's not this Thursday, is it?
No, I think she said it was a week. It might be a little bit farther away than I thought it was. But let's just try and have our idea by Thursday, like what we want to study. Yeah. Yeah. Then we gotta figure out. Yeah, because then I think we've got to figure out how to do it and what we're gonna do, and then we got to turn that into
draft it and whatever. Yeah.
Yeah. Yeah. Okay. Cool. Cool. Well, thank you so very much. Sorry, it's been an off day for me, but Thursday will be better.
I hope that your job interview thing goes well, and good luck.
Okay, cool. Well, yeah, I'll see you in 2 days, but I hope, school goes well and everything. And Thanks for being an awesome group member, Caitlin.
No problem. You have a good day.
Okay,
Bye.
see you. Bye.